Okay, let's have a look at question 8.15. So unlike our previous friction questions, this one is friction on an angle or an inclined plane. So we have a car that weighs 1.2 tonnes and it's on a sloped surface, and we know that the car is just in a position where the friction between the car and the ground will hold it in place. So what we're trying to work out is what is the coefficient of static friction. So in this case here, first thing that we are going to probably need to do is work out the normal force and the frictional force. Okay, so let's start with this question. Right, so first thing we'll do is we'll work out the angle of the sloped surface. So we know from the diagram that the height is 1 and the hypotenuse is 3, and we are trying to find theta. Right, so sine theta equals 1 over 3, and that would make theta equals 19.47 degrees. So we know that that angle in there is 19.47 degrees. So if I draw myself a diagram, this is what we basically have. 19.47 degrees, that's the angle of the slope. We have a car sitting there and we have a weight force, which is mg acting straight down. We have a frictional force which is stopping the car from sliding down the hill, and we have a normal force which is perpendicular to the slope. So the first thing we're going to do is I'm going to first of all resolve perpendicular to that. So we're going to find the normal reaction. Okay, to find the normal reaction, I'm going to draw another little diagram. So we have mg acting straight down. Now the normal reaction force in our case here is acting at that angle. So if I complete the diagram, now that's mg, we are trying to find this one, and we know that that angle in there is 19.47. So to find Rn, we know that cos theta is adjacent over hypotenuse is Rn divided by mg. So Rn equals mg cos theta. But Rn equals mass, which is 1.2 tonnes. Now to convert that to kilograms, so it's times 10 to the 3. G is 10, and cos theta is cos 19.47. So Rn equals 11313 newtons, and round that out to 11.313 kilonewtons. So the normal force to that surface is 11.313 kilonewtons. Okay, so the next thing that I'm going to do now is I need to calculate the frictional force. So the frictional force is acting parallel to the slope, so we're going to resolve forces parallel to the slope. So what do we have? Well, we have mg acting straight down, and we have the frictional force acting in that direction. Okay, so I'm going to try to complete that triangle. So that's what we're trying to find. We know that's mg, and we know that that is 19.47 degrees. Okay, so the sine of 19.47 degrees equals opposite, which is FR, divided by hypotenuse, which is mg. So FR equals mg sine 19.47. If we calculate all that out, m is 1.2 tonnes, change it to kilograms by 10 to the 3, times gravity times sine 19.47, and that will give us 1.2 by 10 to the 3 times 10. Okay, so that gives us 3999.758 newtons, so that equals roughly 3.99 kilonewtons. So that's the frictional force that is stopping our car from rolling down the hill. So to find mu, so all we need to do now is we know the formula for friction, so a frictional force equals mu and our normal force. So in our case here we have frictional force equals mu and the reaction in the normal direction. We're trying to find mu, so we know that FR equals 3.99 kilonewtons. We know that the reaction in the normal direction is 11.313 kilonewtons. We don't know what mu is. So if I rearrange this formula, mu equals FR over Rm equals 3.99 divided by 11.313. 3.99 divided by, so mu is equal to 0.35. Okay, so the coefficient of friction between the tyres and that particular ramp in this case is 0.35.